Good day, class. This is Sir Kenny with another topic in STM006 or General Chemistry 2. Today we're going to discuss Module 16, which is about evaluating enthalpy and entropy in spontaneous reactions. Before we delve in, let us have our lesson objectives. So, by the end of this lesson, you can say that yes, I can determine how enthalpy and entropy affects the spontaneity of reactions. Now, we have already discussed the first and the second law of thermodynamics. We have already differentiated endothermic from exothermic reactions. We have discussed calorimetry, and we have also differentiated spontaneous from non-spontaneous reactions. Today we're going to discuss enthalpy and how enthalpy and entropy affects the spontaneity or kung magiging spontaneous ba or hindi ang isang chemical reaction through the Gibbs free energy computation. Now, when we speak of enthalpy, ito yung kung gaano karami yung heat na inaabsorb or nire-release sa isang chemical reaction at a constant atmospheric pressure. Given that enthalpy is an extensive property, ibig sabihin nakadepende sa kung ilan ang number of moles or coefficient ang meron sa isang substance. So nababago ang value ng ating mga substances depende sa kung gaano sila karami based on their number of moles or kung ano yung kanilang coefficient. Enthalpy of a reaction, delta means change, H is for enthalpy, Rxn is reaction. This is calculated by subtracting the summation of the enthalpies of formation of the products and the summation of the enthalpies of formation of the reactants. So kung mapapansin ninyo, familiar yung ating formula. Kasi ganito rin yung ginagamit natin sa change in entropy. Sa entropy, S itong mga ito. For enthalpy, H. When we speak of enthalpy, ito yung amount ng heat na inaabsorb or nire-release sa isang chemical reaction. When we speak of entropy, it is the measure of disorderliness. Okay? Now, in order for us to better understand this, meron tayo ditong chemical equation. Kagaya ng sa ating change in entropy, meron din tayong table na kung saan ang bawat isang substance ay may kanyang kaakibat na value for the change in enthalpy. Maliban doon, nakadepende rin ang kanilang enthalpy sa kung anong state of matter sila, if they are solid, liquid, or gas. Now, mapapansin nyo sa table dito na may mga zero ang values. Napakarami na zero ang kanilang values. Bakit kaya? Kasi these substances are in their elemental state. Ibig sabihin, they are in their most basic state. At lahat ng mga elements na nasa basic state will always have zero enthalpy. Kasi it doesn't need any energy to form a naturally occurring compound. So, ibig sabihin, lahat ng mga substances na nasa kanilang element form will always have a change in enthalpy of zero. Ibig sabihin din nun, ang mga compounds lang or those that are made up of two or more elements chemically combined, sila lang yung may value ng enthalpy. Kagaya ng sa ating entropy, the first step in finding the standard molar enthalpy of a reaction is to balance the chemical equation, which is done here. So by putting these coefficients, mababalance natin ang chemical equation. Kagaya ng sa ating entropy, importante ang ating mga coefficient. Kasi, kagaya ng sa entropy, enthalpy and entropy are both extensive properties. They rely on the number of moles or the number of substances present, kaya nababago ang kanilang values. The next step, alamin natin ang ating summation of the change in enthalpy of formation of the products. So, ito yung reactant, ito yung product. Paano natin nasabi na ito yung product? Kasi ito yung arrow sign. Siya yung nagdi-divide sa chemical equation into two. The reactant kung saan hindi nakapoint yung arrow and the product kung saan nakapoint yung arrow. So kunin muna natin yung summation of the change in enthalpy of formation of the products. So una, ito yung ating product. The first substance is KCl. So, imumultiply natin yung number of mole sa bawat substance present in the products, saka natin sila ipag-a-add para makuha yung summation. So, the first substance is KCl. Ang kanyang coefficient ay 2. So, yung 2 i-bring down natin dito. Tapos, imumultiply natin siya sa value ng enthalpy ng KCl. For KCl under solid, KCl is negative 436. Now, the unit of the values ng ating enthalpy is in kilojoules per mole. Ito yung amount ng heat na kailangan para magkaroon ng change per mole ng substance. So, KCl is negative 436. So, 2 times negative 436 plus yung susunod na substance which is oxygen. 3 moles. Tapos yung value ng oxygen which is 0. Bakit 0? Kasi nasa element state siya or nasa elemental state siya. Kaya 0 ang value niya. So, kapag pinag-add natin yung ating product dito sa KCl at yung product dito sa oxygen, so, since medyo may problem tayo sa calculator, ang gagawin ko na lang ay unahin ko na lang yung mga may negative na values. So, open parenthesis, negative 436 times 2 plus 3 times 0. So, ang ating summation of the change in enthalpy ng product ay negative 872 kilojoules. Bakit kilojoules? Kasi mole dito at ang unit ng ating enthalpy ay kilojoules over mole. So, makakancel yung mole. So, you will be left with kilojoules. Next naman, the summation of the change in enthalpy of formation of the reactants. So, sa reactants naman, isa lang ang ating reactant which is potassium chlorate. So, same process, imumultiply natin yung number of mole doon sa kanilang enthalpy value. So, for potassium chlorate, it is 2 times, enclose ko lang sa parenthesis yung mga may negative kasi para hindi masira yung ating formula. But, pagdating sa calculator ninyo, sa cycle ninyo, kaya na dire-diretso nyo yung may negative. Okay, the value of KClO3 is negative 492.9. So that means 2 times negative 492.9 is equal to negative 985.8. So this is the standard molar enthalpy of formation for the reactants. What's left for us to do is ima-minus natin itong nakuha nating reactant dito sa product by using the formula product minus reactant. So this is for our product and this is for our reactant. Kapag pinag-subtract natin sila, and close na natin muna silang lahat sa parenthesis. So, negative 872 minus negative 985.8. Our change in enthalpy of the reaction is equal to 113.8 kilojoules. What does that mean? Kapag positive ang ating change in enthalpy, then that means the reaction is endothermic. Kapag sinabi nating endothermic, the system will absorb the heat. Kapag negative naman ang ating change in enthalpy, ibig sabihin, the system will release the heat, magiging exothermic. Since our answer here is positive, ibig sabihin, this is endothermic. Yung value na nakuha natin, since positive, yun yung amount na i-absorb ng system. Okay? Let's have another example. You may have noticed na kung ano yung example natin nung sa Module 15, sila rin yung examples natin sa Module 16 para hindi kayo masyado mahirapan. Tapos para makita nyo yung continuity. Okay, first step uli, balance the chemical equation by giving the following coefficients to each substances. Now that we have already balanced the chemical equation, what we are going to do next is to determine the summation of the change in enthalpy of formation of the product, pati yung sa reactant. So, unahin natin si product. So, the summation of the change in enthalpy of formation of the product is equal to, ito uli yung ating product kasi dito nakapoint yung arrow, so ito yung uunahin natin. So, 2 ang ating coefficient for water, kaya maglagay ng 2 mole. Next, hanapin natin ang value ng water na liquid. So, ang water na liquid ay negative 285.8. So, negative 285.8. So, ipag-multiply natin ito. Saka natin ipagpa-plus sa product ng kabilang substance. Next naman na substance, 2 mole dito sa SO2. kaya 2 mole, times the value of SO2 na gas. So the value of SO2 na gas is negative 296.2. So using our calculator, unahin muna natin si water. Kagaya ng kanina, unahin ko muna yung ating mga may negative kasi medyo hindi scientific yung ating scientific calculator. So negative 285.8 times 2 plus the other substance. Yung una yung may negative, negative 296.2 times 2. So that means our summation for the change in enthalpy of formation of the product is negative 1,164 kilojoules. Bakit uli kilojoules lang? Kasi unit natin ay kilojoules over mole. May mole dito, so cancel mole, you will be left with kilojoules. Next, let us have the reactants. So for the reactants, ito yung reactants natin kasi sila yung kung saan hindi nakapoint yung arrow. Umpisahan natin kay H2S, tapos isusunod natin si oxygen. So, si H2S, ang kanyang coefficient ay 2, kaya may 2 mole tayo dito. Next, our value for the enthalpy of H2S is negative 20.6 kilojoules per mole. Next, yung susunod na substance naman na 3 yung oxygen, kaya 3 mole. Oxygen na gas is 0. Bakit 0 ulit? Kasi they are in their elemental form or elemental state, kaya 0. So, kukunin natin yung kanilang summation of enthalpy of formation for the reactant. So, parenthesis, negative 20.6 times 2, kasi yun yung coefficient ng H2S, plus yung sa oxygen naman, 3 mole times 0. So that means our summation for the change in enthalpy for the reactant is negative 41.2 kilojoules. Next, pwede natin gamitin itong formula dito sa taas. So product minus reactant. So this is for our product. This is our reactant. So ilagay natin sa calculator. Negative 1164 kilojoules minus negative 41.2 kilojoules. So that means our change in enthalpy of the reaction is negative 1,122.8 kilojoules. So far, madali lang siya kasi katulad lang siya ng ating discussion sa entropy. So madali lang siyang sundan. Now we are going to discuss how enthalpy relates with entropy. At kung paano natin malalaman kung ang reaction ay magiging spontaneous or non-spontaneous with the use of this formula. This formula is for the Gibbs free energy. So, nakadepende ang Gibbs free energy sa number 1, enthalpy change ng system. Number 2, entropy change ng system. Pangatlo, the temperature at which the chemical reaction takes place. So the change in a quantity called the Gibbs free energy enables you to be able to determine if a reaction is spontaneous or not. So kapag ang lumabas sa ating computation ay positive ang value, then that means hindi spontaneous. Ibig sabihin, kailangan ng external action or kailangan ng intervention or kailangan ng work doon sa system para magkaroon ng reaction. The other term for spontaneous is endergonic. Yung value na lalabas, ibig sabihin yun yung kailangan na amount ng heat na i-introduce doon sa system para magkaroon ng change or para magkaroon ng reaction. Kapag ang Gibbs free energy natin ang lumabas ay negative, ibig sabihin it is spontaneous. Kapag lesser than 0, so ibig sabihin negative, any value ng negative, magiging spontaneous yung reaction. Ibig sabihin, the chemical reaction will take place even without intervention, even without work being introduced in the reaction. The other term for spontaneous is exergonic. So our formula for the Gibbs free energy is the change in G or the change in the Gibbs free energy is equal to the change in enthalpy minus the product of temperature and the change in entropy. where delta G is the change in Gibbs free energy, the delta H is the change in enthalpy, T stands for temperature, which should be in Kelvin, and delta S is the change in entropy. So gamitin natin yung example natin doon sa entropy at sa enthalpy. So ito yung example natin kanina. So this is the example in number 1 in our discussion in enthalpy na diniscuss natin kanina lang, and entropy which we discussed last meeting or in module 15. So ibig sabihin nakuha na natin yung value ng delta H at ng delta S, where the delta H is 113.8 kilojoules. Ito yung kanina. And next, our delta S is 494 joules over Kelvin. Ito yung discussion natin nung last meeting. Ngayon naman, we have to calculate the change in the free energy if the reaction happens at 30 degrees Celsius. Remember, naka-Celsius tayo, ang temperature natin ay dapat nasa Kelvin. So, in order for us to convert Celsius to Kelvin, yung Celsius dadagdagan natin ng 273.15. So, from Celsius to Kelvin, your value in Celsius plus 273.15. Next, let us substitute the value. This is our formula. By substituting the value, you will have this one. So, our change in enthalpy is 113.8 kilojoules, kagaya ng nandirito. 113.8 kilojoules. Now, we have to convert this to joules. Bakit? Kasi yung unit ng ating entropy ay nasa joules. So, in order for us to proceed, kailangan parehong joules ang unit natin. So, para maging joules, yung kilojoules imumultiply natin sa 1,000. So, 113.8 times 1,000 is 113,800 joules. So, ito na yon. Next, let us find our entropy. The entropy is 494 joules over Kelvin. So, ito yung 494 joules over Kelvin. Next, the temperature. Ang temperature natin ay dapat nasa Kelvin. So, 30 plus 273.15, we will have 303.15 Kelvin. So, tignan natin yung mga units natin. Ang mga units natin, makakancel ang Kelvin. Ang matitira ay joules. Bakit hindi makakancel yung joules? Kasi yung mathematical operation natin dito ay minus. So, kapag plus or minus, hindi nagiging squared ang unit or nakakancel ang unit. The unit remains the same. So, i-compute natin. So, 113.8 times 1,000 is equal to 113,800 minus the product of the entropy and the temperature. So, 494 times 303.15. So, this is the value of our Gibbs free energy. So, that means, since negative siya, the chemical reaction is exergonic or spontaneous. It doesn't need intervention or work to be done on the system in order for the chemical reaction to take place. Okay? So let us have another example. Yung example number 2 naman na kahapon at nung kanina. So this is example number 2 in our discussion in enthalpy kanina and entropy which was in module 15. So nakuha na natin yung delta H and delta S. What's left for us to do is to substitute the values. So the formula is delta G is equal to delta H minus T delta S. Our delta H is negative 1,122.8 kilojoules. Yung dito sa ating computation kanina. At nung kahapon, ang entropy natin ay negative 391.2 joules over Kelvin. Next, nangyari daw ang chemical reaction at 75 degrees Celsius. So, let us substitute the values. Ang unit natin sa entropy ay joules over Kelvin. So, ang H dapat natin ay naka-joules, ang temperature dapat natin ay naka-Kelvin. So, converting these to joules, times 1,000, so it will become negative 1,122,800 joules. And converting 75 degrees Celsius to Kelvin plus 273.15, it will become 348.15 Kelvin. So, substitute the values. This is our delta H. This is our change in entropy. And this is the temperature change. So, by solving it using our calculator, since negative ang ating H and close ko siya sa parenthesis kasi may topak ang ating calculator pagdating sa mga negative. So, negative 1,122,800 kilojoules minus the product of the delta S, which is negative 391.2 times 348, sorry, 348.15. So our answer is this one, negative 986,603.72 joules. So since negative uli siya, then that means this reaction is exergonic or spontaneous. Nagigets ba? Now let us try answering na mula sa umpisa ay sasagutan natin. Isosolve natin mula sa enthalpy, papunta sa entropy, papunta sa Gibbs free energy. This is our example. Cesium chloride plus aluminum oxide to produce cesium oxide plus aluminum chloride. So, the first step is to balance the chemical equation kasi remember, our enthalpy and entropy are extensive properties. Ibig sabihin, nababago ang kanilang value depende sa number of moles present per substance. Okay? So, pag binalance natin, ito yung lalabas sa coefficients. 6, 1, 3, 2. Given na ang ating enthalpy at ang entropy. So sa quiz or sa exam, given na rin ang ating enthalpy at entropy para hindi na kayo masyadong mahirapan na maghanap. In balancing, pag-usapan namin ni Sir Gemar kung ibabalance ba namin or hindi. So the first part is, pwede nating unahin ang kaninong formula ulito, yung mga H. So this is enthalpy. So hanapin muna natin yung ating enthalpy value. So familiar na tayo sa formula. So for the product, kunin natin yung ating summation of the change in enthalpy of formation of the product. Ito yung product natin. So 3, kaya 3 mole. CS2O, ang enthalpy niya ay negative 317.6. Kaya 3 times negative 317.6. Ngayon naman, i-add natin yung product ng susunod na substance. Sa susunod na substance, ang kanyang coefficient ay 2 mole, kaya 2 dito. Next, ang ating enthalpy value for aluminum chloride is negative 706.5. Kaya times negative 706.5. Ilagay natin sa calculator. So, kagaya nung kanina, uunahin ko muna yung mga may negative na value kasi may topak ang aking calculator. But if you are going to make use of your scientific calculators, kahit na ano yung unahin ninyo, okay lang. So, I will enclose this in the parenthesis first. This is negative 317.6 times 3, which is the coefficient of the cesium oxide, plus yung susunod na substance natin, 2 mole, negative 706.5 times 2. So that means our change in enthalpy of formation for the product is negative 2,365.8 kilojoules. Next naman, for the reactant, ito yung ating reactant. So, 6 dito. 6 ang nakalagay dito kasi 6 yung ating coefficient. Next, the value for cesium chloride, ang kanyang enthalpy value ay negative 433. Kaya negative 433. Next, the other substance is aluminum oxide. Walang nakalagay na value dito, pero since walang nakalagay na value or coefficient, it will be considered as 1. So 1 mole. tapos times the enthalpy value of aluminum oxide, which is negative 1669.8. So ayan. By putting that in our calculator, it will be, unahin ko lang negative 433 times 6 plus negative 1669.8 times 1. Our summation for the enthalpy of formation of the reactant is negative 4267.8, which is already shown here. So meron na tayo ng product at ng reactant. Ang gagawin na lang natin ay ima-minus. So product minus the reactant. This is our product. This is our reactant. So ang lalabas niyan kapag kinalculator mo, since naka-negative siya, ilalagay ko siya sa parenthesis. So negative 2365.8 minus negative 4267.8. So ang lalabas na ating change in enthalpy for this reaction is 1902 kilojoules. So ibig sabihin nito, since positive siya, then that means the reaction is endothermic or papasok yung heat sa system. Now we are already done with the change in enthalpy. Let's go with the change in entropy. Same process lang yan. Ang nagkaiba lang ay yung mga values natin dito. Okay. So for the product, ganun uli. Kunin natin itong 3 na mole. Nandito yung 3 mole. Tapos yung value ng ating entropy for the cesium oxide. Ang entropy niya ay 146.8. So 146.8. I-multiply ito. Tapos, susunod na substance, 2 mole. Kaya 2 yung nakalagay dito. For aluminum chloride, it is 109.3. So 109.3. Ipag-multiply natin yung 2 tapos yung 109.3. Pagkatapos natin i-multiply, ipag-add natin itong dalawa. Ang lalabas dyan ay 653 joules over Kelvin. Bakit joules over Kelvin? Kasi joules over mole Kelvin ang ating unit for entropy. May mole dito, so cancel mole. Ang may iwan ay joules over Kelvin. Kaya joules over Kelvin ang unit natin. Next naman for the reactant, same process lang din sa enthalpy. Ang nabago lang ay yung kanilang value dito. So, this is our reactant. 6 ang cesium chloride. Kaya 6 dito, kaya maglalagay tayo ng 6. Imumultiply natin yan sa value ng entropy, which is 101.2. Okay, next. For the aluminum chloride, walang nakalagay na number, pero considered as 1, kaya 1 mole. The entropy value is 51, kaya 51. So ang lalabas sa summation of the change in entropy ng reactant ay 658.2 joules over Kelvin. Same process, i-minus natin yung ating mga nakuha. Product minus the reactant to get the overall change in entropy. So, 653 kilojoules, ito yung sa ating product, minus 658.2 joules over Kelvin, which is our reactant. Ang lalabas ay negative 5.2 joules over Kelvin. Ano ang ibig sabihin uli ng negative kapag entropy? Ibig sabihin mas umayos. Ibig sabihin nabawasan ng disorderliness. So negative entropy. Last step is the Gibbs free energy. Ano daw ang ating change in energy kung ang reaction daw ay nangyari at 25 degrees Celsius? So the formula for the Gibbs free energy is here. So delta H minus T delta S. Ano ang mga values natin? Ang delta H natin ay 1902 kilojoules, pero kailangan nating i-convert ito sa joules kasi ang unit ng ating entropy ay joules. So this times 1,000, you will have 1,902,000 joules. Next, our delta S is negative 5.2 joules over Kelvin. Our temperature is 25 degrees Celsius plus 273.15. Kasi ang unit ng temperature natin dito ay Kelvin, so the Celsius must be converted into Kelvin by adding 273.15. Next, substitute the values. For delta H, it is 1,902,000 joules minus the product of the delta S and delta T. So delta S is negative 5.2 joules over Kelvin. T is 298.15 Kelvin. So kapag ilalagay natin siya sa calculator, since hindi naman negative to, as is ko na siyang ilalagay. So 1902 minus, ilagay natin sa parenthesis kasi may negative. So negative 5.2 times 298.15. So ang lalabas na value natin ay 1,903,550.38 joules. Bakit joules? Kasi ang unit natin dito ay joules over Kelvin. Cancel Kelvin kasi may K din dito. Ang may iwan na lang ay joules. Bakit hindi makakancel uli? Kasi subtract ang nakalagay dito. Kapag add or subtract, hindi magiging squared or hindi makakancel ang mga units. So magre-retain yung joules na unit. Given that our Gibbs free energy is energy, then the unit for energy is joules. Kaya tama ang ating sagot. Kasi yun yung nasa formula natin. Now, since our Gibbs free energy is positive, then that means the reaction is endergonic or hindi siya spontaneous. Itong value dito, ito yung kinakailangan para magkaroon ng reaction. So, that is Gibbs free energy. And that concludes our lesson for module number 16. You can now try answering your modules.